everyone, I'm Joy and today we are going to see the carrier sense multiple access. Now what is CSMA CD? The CSMA CD technology was designed for early wired local area network, specifically for bus topology networks. Nowadays the CSMA CD is not used because the most of networks are either star topology or point-to-point network. But the CSMA CD is still supported if you are using the bus topology. The CSMA CD does not use acknowledgement in order to confirm the transmission. We have seen that in the pure Aloha or the slotted Aloha, it totally depends on the acknowledgement. The Aloha method dependent on the acknowledgement. But the CSMA CD does not rely on the acknowledgement. Okay? So now let's see what are the steps for CSMA CD. Now these are the steps which should be followed by each device if the device wants to send some data. These are the 4 steps. Let's see these steps one by one. So the first step is to check if the sender is ready for transmitting data packets or not. Like if sender is having any data to send or not. If the sender is having any data to send, in the next step, the sender will sense. Sender will sense whether the link is idle or not. Okay, the sender will check whether the link is idle or not. Idle means any data transmission is happening in the link or not. If the link is idle, if no data transmission is happening in the link, the sender will transmit the data. And while transmitting the data, the sender will continuously check for collision. So in the third step, the sender is doing 2 things. The first one, the sender is sending data. At the same time, the sender is also checking whether there is a collision in the link or not. Okay? And during the third step, if the data is transmitted and no collision is sensed by the sender, it means the communication was successful. The data was sent successfully. Okay, so you can see that these are the 4 steps which is followed by all the devices. But still, I know you are confused that how the sender knows that there is a collision. Okay, so let's see that how sender finds that there is a collision in the network. Now you can see that there are 4 devices A, B, C and D are connected via a bus topology. Suppose device A has some data to send. So like we just discussed that these 4 steps are followed by each and every device in the network. So if A wants to send some data, it will first sense the channel. After sensing, if A finds that the channel is idle, A will send data to the receiver. So you can see that A has sent data to device C. Now what happens if 2 devices are sending data at the same time? Suppose B and D wants to send some data to C. Now B and D wants to send some data to C, so they will first sense the channel. Because they want to send data at the same time, they will first sense the channel at the same time. After sensing, they both will find that the channel is idle, so they will send data. And after some time, their data will be collided with each other. And this thing is known as collision. And when there is a collision in the network, no device can able to receive proper data. All the devices will receive is junk data. Still, the question remains that how the station knows that there is a collision. So let's see that. Suppose device A wants to send some data to C. Because they are following the CSMA CD method, the device A will first sense the channel. After sensing, if A finds that the channel is idle, A will send data to C. Now you can see that this data which is sent by A to C in the graph. Now you can see that the data, when A sends data to C, in the cable there will be just signal, and signal is having different levels such as 0 and 5. 0 means 0 bit and 5 it means 1 bit. So A has sent this signal to C and C will receive the signal. Now let's consider the second situation in which B and D wants to send data at the same time. So they will first sense the channel. After sensing, they found that the channel is idle, so they will send the data. Now the data which is sent by B and D, in the link they will just become signals, and that can be seen on the screen. So this is the data which is sent by B to C. This signal is the data which is sent by B to C, and this signal is the data which is sent by D to C. Now this signal is traveling from left to right, and this signal is traveling from right to left, and after some time this signal will collide with each other, and when the signal will collide, the signal will become something like this. Now if you notice, now the signal is changed drastically. Now when C receives from the 0, C can understand that it is 0 bit, but from, let's say, 7 volt, 7 volt, 9 volt, 8.5 volt, in that case C is not going to understand that whether it is 1 bit or 0 bit or something in between that. So when C receives signal which is having drastic change in the voltage level, in that case it is going to understand that there is a collision in the network. And when the sender B and D gets to know that there is a collision in the network, they will stop sending the data, and after some time they will try to send the data again. Now let's see the flow chart of the CSMA CD. K is number of attempts, like how many times the sender can retransmit if sender is part of collision. Like if sender is sending data and sender detects that there is a collision, so the sender will wait and after some time it will send again. So when it is sending again, the value of the K will be incremented, and the number of attempt K is limited for each and every device. No device can attempt retransmission over and over again, because if any device is doing retransmission over and over again, so it will just create so much traffic in the link and it will increase the probability of the collision in the network. Now in the first step, like we just saw, before sending data, the sender will sense the channel using any of persistent method. After sensing, if the sender finds that the channel is idle, the sender will send data. Now when the sender is sending data, at the same time it will continuously check whether there is a collision or not. So like we just saw in the third step, the sender will send data, at the same time it will check whether there is a collision or not. Okay, so in the process of sending data, if the sender finds that there is a collision, the sender will stop sending data and it will attempt for the retransmission. So right now the sender will transmit and receive, it means it will sense until there is no collision detected. If the collision is detected, then the sender has to do retransmission. Suppose if collision is not detected, it means the transmission is successful. If the collision is detected, the sender will send the jamming signal. Now sender will send the jamming signal. Why it is sending the jamming signal? Jamming signal is used to tell every device on the network that there is a collision in the network and please wait for some time. Because sender finds that there is a collision, it is informing the remaining devices that please do not send data right now, please wait for some time and after that try to send data. So sender will send the jamming signal and it will try to do attempt one more time. So the value of the K will be incremented, it will become 1 from 0, K if K is greater than Kmax or not. So maximum attempt which is allowed for each device is 15. So if it is not greater than 15, in that case it will choose the random number between 0 to 2 raised to k minus 1. After that it will wait for some time, that is equal to r into propagation delay or r into transmission of the frame, and after some time it will send the frame again, and this flowchart will keep going until the transmission is successful. Okay, so this is it for this session. If you have any doubt, you can ask me in the comment section. Thank you so much.